Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. Right, grade 11s, carrying on from Redox. Okay, in the session outlined, we're going to do a little bit of teaching quickly, just the last little bits of it, and then we're also going to have a look at an exam question papers, possibly maybe 2 or 3, just to have a look at how these questions are asked in an exam. Since exams are coming up in about, if I look at it, just in more than a month's time. Okay, so there's 2 definitions. We already know the definition of oxidation. We already know the definition of reduction. But then there's 2 other terms that come into play, which is oxidizing agent and reducing agent. All right. Now these work a little bit differently. Okay. The oxidizing agent, because we see oxidized there, we think it works with oxidation. No, it does not. Okay. The oxidizing agent, first of all, the definition is it is the substance causing the oxidation of the other substance the substance causing the oxidation of the other substance and is itself reduced. So in other words, the substance that gets reduced. Now, in other words, the substance that gains the electrons would be the oxidizing agent. All right. The substance that gains an electron would be called the oxidizing agent. Okay. Let's take, for example, here, if we have oxidation half reaction. Let's use the oxidation half reaction of magnesium becomes Mg2 plus 2 electrons. All right. We say that magnesium is oxidized, and that would be, of course, the reducing agent. Okay. But if we have the oxidizing half reaction, which I'm still going to use for both, all right, O2, sorry, not O2, it's just O, sorry, plus 2 electrons becomes O2 minus. We say that oxygen is reduced, all right, oxygen is reduced, but it is the oxidizing agent because it's the substance that is reduced. So we identify the substance that is reduced, that is the oxidizing agent. However, the reducing agent, all right, first of all, this is the substance, okay, this will be the reducing agent, reducing agent substance, okay, which is the oxidation reaction, okay, half reaction. This is the substance causing the reduction of the other substance and is itself oxidized. Sorry, yes, oxidized. Is itself oxidized. All right. So those are the definitions between the difference between the 2. All right. When they ask you to identify a oxidizing agent and the reducing agent. The oxidizing agent, you know, is the substance that got reduced. So you look at your reduction half reaction, look at which substance got reduced, and your oxidation or your reducing agent, you look at the substance that got oxidized. Okay, that's the easiest way to identify which is which. So let's take another example. So let's use magnesium and sulfur. Okay, so let me map everything out in detail. So let's take an oxidation half reaction. Okay, we'll use the same one. We have magnesium. Mg becomes Mg2 plus 2 electrons. Okay, we are showing, okay, that the substance lost 2 electrons. Okay, hence it became that. Okay. Then we'll take the reduction. I kind of wrote it in the wrong color. Doesn't matter. It's a new example. We'll just go with it. Right, reduction. And let's take sulfur. So S plus 2E now becomes S2 minus. Okay, showing that it got reduced, that it accepted 2 electrons. This is showing that it lost 2 electrons. Alright, it lost 2 electrons. Okay, so now the definition previously. Okay, for the first reaction, let's maybe put this in one entire net reaction. Let's maybe do that. Okay, if we do that, we'll get this. Okay, these electrons will cancel out. We'll have Mg plus sulfur on the left hand side will give me Mg2 plus S2 minus. Now let's say we got this reaction here and they ask identify the oxidizing agent. Now the oxidizing agent is the substance that causes the oxidation of the other substance and is itself reduced. In that whole definition, you need to just remember the last part, is itself reduced. Which substance in this reaction here, I might add, let's maybe use another color to maybe map it out nicely, was reduced? I know, sulfur. Sulfur was reduced. It was S and became S2 minus. So it must have gained 2 electrons. So sulfur is my oxidizing agent. However, what's my reducing agent? Alright, my reducing agent, alright, is the substance that causes the reduction of another substance of the other substance and is itself oxidized. Which substance was oxidized? Magnesium. Right? Showing it lost 2 electrons. Right? 2 plus is more positive than Mg0. Alright? It's more positive. So if a substance becomes more positive, we know it's been oxidized, therefore we know it's the reducing agent. If a substance becomes more negative, then we know, hey, it was reduced, so hence oxidizing agent. So the names work differently. Right? Oxidizing agent works with reduction. Reducing agent works with oxidation. That's all you got to know. All you got to remember. So in a quick little exam quickly. November 2016. Question 9 seems to be the oxidizing or redox section here. 14 marks. They say silver Christmas tree can be made by placing copper wire shaped in the form of a tree into a silver nitrate solution. The unbalanced equation of the reaction is as follows. Copper solid plus silver nitrate, as it says there, and becomes copper nitrate and plus silver. Now, first question, define the term oxidation in terms of oxidation number. Now, you cannot just use your normal oxidation definition. Right? Oxidation is loss of electrons. You can't say that. You got to explain it with reference to oxidation numbers. So that must be, so oxidation numbers or something with oxidation numbers needs to be mentioned in your definition somehow. 9.2, this 9.2.1 all the way down to 9.2.4. Okay. First, they ask us for the formula for the reducing agent, the name of the oxidizing agent. 2 different questions. Don't give both names or both formulas. Okay, the formula means this chemical or molecular formula here, somewhere here. The oxidation half reaction, and 9.2.4, the balanced net ionic equation using the ion electron method. Okay, which is basically what I did here. On this layer, something like this. Okay, and then let's see for 9.3, use oxidation numbers to explain why to explain your choice of the oxidizing agent in question 9.2.2. all right, that should take us about 15 minutes to complete, because there's a lot of thinking. There are a lot of things we need to make certain of here and make sure of, so we're going to give 15 minutes, and it's now 22. So at about 5:2, right, we will mark. Alright, let's give this one a mark. Let's mark the first one. So the first question asks us to explain oxidation 9.1 in terms of oxidation numbers. Explain oxidation in terms of oxidation numbers. Now we know oxidation is loss of electrons, but when it comes to oxidation numbers, oxidation can be explained like this. Oxidation is the increase in oxidation numbers. Alright, it's increase in oxidation numbers. We saw that in the example, alright, that we did earlier. There was an increase in oxidation number. If there's an increase, something's become more positive, then we know it's oxidized because it's lost electrons. Okay, electrons are negative. So if you lose negativity, you become more positive. Alright, if something is, if there's a decrease in oxidation numbers, then we know that substance has been reduced. Okay, very teachable moment here and a learnable moment right now. Okay, oxidation explained in terms of oxidation numbers is increase in the oxidation numbers. That will be oxidation. Alright, 9.2.1. 9.2.1. Write down the following for the reaction above. The formula of the reducing agent. Now, what is the reducing agent? The reducing agent is the substance, of course, that got oxidized. So, from the left-hand side, I can see that the substance that was reduced was... Sorry, the substance that was oxidized is copper. So the formula would just be, as the question suggested, Cu brackets S for solid. Copper, that's the formula. That was the substance that was oxidized. So therefore, that's the reducing agent. Now 9.2.2 is the name of the oxidizing agent. Alright? Name of the oxidizing agent. Now we've got to write it out in English. Okay? But this one is not as simple as you think. It is silver. Alright? But silver is an ion. If you look on the table of reduction potentials, right? The long list of tables there. So you got to write out the full thing. You got to write out, if you wrote silver, you'll just get 1 mark. If you want 2 marks, you got to write out silver ion. Alright? And the reason for that is if we come back here, and we go all the way down to our table, alright? 4A or 4B, doesn't really matter. I'm going to use the bottom of 4A. Silver is Ag. Where's Ag? Ag. There we go. Alright. Okay. There we go. There it is over there. So silver ion. So that's Ag plus. Alright. But they didn't ask us to give the formula. They asked us to give the name. Okay. So silver ion. It's because of this. Ag. Okay. That's the oxidizing agent because silver was actually reduced. Okay. Oxidizing agent causes the oxidation of the other substance and is itself reduced. Reducing agent causes the other substance to be reduced, alright, and is itself oxidized. Okay. 9.2.3, the oxidation half reaction. Well, it's the half reaction of copper. Okay. So there are more than one, or there is more than one copper half reaction. You got to find out which one this is. So I can see nitrate here has a 2 at the end of it. So we know how copper and nitrate will bond, because copper must make 2 and nitrate must make, I think, negative 1. So they cross over to yield Cu brackets NO3 2. Alright, so that's how they formed. Just make the brush size bigger. Eraser size bigger, sorry. So therefore we got to go find the copper 2 plus half reaction. So if we scroll down here, so there we go, the copper 2 plus half reaction. Alright, it's that one. So just got to write it in this case from right to left. Let me just go back to the question here. There it is. So the oxidation half reaction, Cu becomes Cu2 plus 2e. Alright, that was 9.2.3. And 9.2.4, I think, was the balanced equation of balanced net ionic equation using the ion electron method. Okay, basically what I did previously. So oxidation half reaction on top, Cu2 plus 2e. The silver one, which is this one, so that's Ag plus an electron, and that gives me Ag, just normal Ag. And now I've got to balance this equation. Okay, so the first thing that I need to do is I need to double up the electrons here. So I need to multiply everything here by 2. And if I do that, I'll get 2Ag plus 2 electrons, 2Ag plus 2 electrons plus 2Ag. So I've now made the electrons the same. So now if I want to balance them, they'll cancel. And I'm left with, I'll write it in a different color, 2Ag plus, sorry, the oxidation one first, so Cu plus 2Ag plus becomes Cu2 plus 2Ag, and that's the net and balanced ionic equation. Alright, that's for 9.2.4. And we're going to need to use another layer for this one to get the last question in, which is 9.3. And it asks us to use oxidation numbers to explain why, or explain your choice of the oxidizing agent in 9.2.2. So they're tricky here to kind of doubt yourself, but not us, because we know what we're doing. All right. So oxidizing agent is indeed silver, or the silver ion. Okay, and we'll just use oxidation numbers to prove that. So we'll write down the unbalanced equation, or we don't need to write down the unbalanced equation. We can write the balanced one now for 9.3. Sorry, not sure why that layer is invisible. There we go. 9.3 Cu plus 2Ag NO3. Okay, now becomes Cu brackets NO3 2 plus 2Ag. Okay, right, got that. Makes sense. Well, we can see here copper oxidation number 0, silver 0. We just want to have a look at the oxidizing agent. So now that we've got this, we can see silver is the oxidizing agent, which is the number we chose. So we got that. So all we need to do is just figure out what's happening here. So oxygen, we got 3 times minus 2. Okay, silver or nitrogen, we just get a periodic table out here quickly. Then I'll be able to tell you how much nitrogen is. Nitrogen, I think it's minus 3. Yes, minus 3. And silver here should be silver. Where's Ag here? Where's Ag? Okay, so I've got minus 3. That's minus 6, and this is minus 3. So that's minus 6 plus minus 3. Grade 11s, I've just realized that we are doing the silver ion from the, remember this is a redox reaction. It's a reduction half reaction. So remember the reduction half reaction was Ag plus electron gave us Ag solid. So unfortunately we can't just work it out normally. We see that the charge on silver there is positive 1. So the charge on silver here will also be positive 1. So we just clear this out here quickly because of that equation there, because we know it's redox. So then if that's positive 1 on the left, and we see silver is now gone down to 0, okay, so therefore we can say Ag plus oxidation number Okay, Ag plus oxidation number changes from +1 to 0. Okay, you can write the number 0 or the word 0. Okay, that's gaining electrons. Alright, other words, I would say reduced. Gain electrons, which is reduction. Alright, or is reduced. And that'll end off the question. Okay, so we've got to pay attention to that. That silver has an ionic equation, and it's the silver ion. Okay, since we used it previously over here, let me just make this layer invisible quickly. Alright, here we go. The silver ion was the oxidizing agent and not the silver compound or the silver element or the silver atom, the silver ion. Alright, so that's why it had to be equal to +1 here. Okay, because that's the charge on silver. And that ends off that question in this paper, which is 2016. Okay, question 9 of the 2017 paper. We're going to do this one now. They said there's a reaction between dichromate ions and iron 2 ions. And they give a reaction though down there below, and they ask us to determine the oxidation number of chromium in Cr2O7 minus, 2 minus. Okay, well, what we do here, question 9, is we know that the oxidation number of Cr2O7 minus 2, the oxidation number must obviously equal to minus 2. All the oxidation numbers must equal to minus 2. So here we've got 7 multiplied, well, let me write that like that, 7 multiplied by minus 2, and we've got 2 times x. Okay, so, oh, there must be a plus sign in the middle here. Let me just write this properly. 2 times x, right, plus. Okay, so obviously we've got 2x plus minus 14, so let's just write minus 14 is equal to minus 2. Alright, so let's see if this is going to work. Alright, so we've got minus 2 plus 14, and then we've got 2x is equal to 12. Divide both sides by 2, and therefore x, which is the unknown, alright, which is equal to positive 6. Alright, now it's not math, so we have to say, therefore, chromium is equal to positive 6. Alternatively, we could write Cr6 plus. Okay, but it's equal to positive 6. That is the oxidation number of chromium in Cr2O7 minus. Let's put that back up again, so we can all see how we achieve that answer. Define reduction in terms of electron transfer. Okay, so this was 9.1. I'll do 9.2 on the side because I can. I'll just do 9.2 here. Reduction in terms of electron transfer is reduction, okay, is the gaining of electrons, or is the gain of electrons. Okay, don't just write gain of electrons. Okay, that's not a full sentence. Okay, still keep your sentences nice and full. Right. Right, the next one, 9.3. Write down the formula of the substance that undergoes oxidation. The formula. Explain the answers in terms of oxidation numbers. Okay. Now the formula that undergoes oxidation, let's have a look here. That equals positive 1. That's positive 1. That's positive 1. No change there. That is positive 6. That goes down to positive 3. Ah, iron. Iron 2 plus must be the formula that goes up to oxidation. Alright, that's 9.3. Fe 2 plus. Alright, and the reason why is because the oxidation number increases. Alright, what does it increase from? It increases from 2 plus to 3 plus. So it goes up from positive 2 to positive 3. Okay, so it increases from +2 to +3. So you can definitely see that it has lost an electron. It's become more positive. If it went down from positive 2 to positive 1 to Fe plus, then you would have gained an electron, right? Because electrons are negative. This is awesome. All right, 9.4 says write down the formula of the oxidizing agent. Now remember, the oxidizing agent is the substance that got reduced. All right, and the substance that got reduced, well, you can either write two answers here. You can either write Cr6 plus, which is the charge on chromium, or write down Cr207 minus 2 or 2 minus, either one of those. I personally just advocate to write down the entire thing, bearing in mind that only this got reduced. Okay, but either or is up to you. I said I'd do 9.5 because you guys can see it. Write down the reduction half reaction. So that would obviously be of the reaction of the oxidizing agent. So we have to go look on the periodic, not the periodic table, the standard reduction table. We just got to go find chromium or dichromate, and there is one right here for us. Okay, so we just copy and write down that whole thing. So that is Cr207 to minus, sorry, not 07, that's 07 for oxygen, plus 14H plus, which is hydrogen, plus 6 electrons. All right, goes to 2Cr3 plus 7H2O. This is fully balanced already. Fully balanced, right? Just taken straight from the table. It's easiest to spot it on table 4A because it was right at the top. 4B would have been at the bottom. Okay. And question 9.6, which is our final answer, write down the balanced ionic equation for it. Okay. So 9.6, I'll write quite close up here. So we obviously know the oxidized was Fe2 plus, so that's Fe2 plus becomes Fe3 plus 1 electron. And we can see the second one was Cr207 2 minus plus 14H plus 6 electrons. That yielded 2Cr3 plus 7H2O. Okay, now we can see that our electrons are obviously out of balance. So let's go balance it. We need to multiply the top one by 6, which becomes 6 Fe2 plus 6 Fe3 plus 6 electrons. Okay, now they can cancel. And what I'll be left with is Cr207 2 minus plus, oh, let's actually write it like this. Let's actually write down the iron one first. 6 Fe2 plus Cr, actually just looks better, it actually looks better writing it this way. Just better not to write the ion first. It doesn't really matter, to be honest. Minus plus 14H plus 6 Fe2 plus, looks much better, looks much neater. Alright, gives me 2Cr3 plus 7H2O plus 6 Fe3 plus. And that's the net ionic equation, balanced out, all ready to be used, and yeah, all set out. Alright, this one was not too difficult either. This one was pretty easy. Alright, so I hope you enjoyed this question, or these questions from these papers. As you can see, the exam are not that tricky. Alright, it's actually pretty much basic as well. Alright, same as from the activities that we've done in class. Okay, very simple, to the point, lots of definitions, but we're working a lot with oxidation numbers, and also just checking that we can obviously form a balanced equation of the net of the net as a result of the two half reactions. So thank you, grade 11s, for joining me on tonight's session on redox reactions. This wraps the section up. because we look through exam questions. We know we always wrap up the section by looking through exam questions and taking you through past papers. So thank you so much for joining us for the session. And we start officially our revision section from the next tutorial. So thanks so much for joining us here on the last topic. Don't forget to like, comment on this video, as well as subscribe to our YouTube channel, Good Better Best Online Videos, and we'll catch you in the next one.